Hello everyone, welcome to today's video. In this video, we will be talking about learning from observation and we will be discussing about the different forms of learning. So let us begin. Talking about learning from observation, basically the primary aim of artificial intelligence is to make a system or a machine intelligent. So in order to make a machine intelligent, the system or the machine has to learn. There are several ways in which the system can or the machine can learn from the environment. However, before we proceed to the different types of learning, it is important for us to understand the general model of learning agents. So there is basically a general model of the learning agents which comprises of several components. So if I am talking about the general components, essentially I mean that we have several factors like first one is a critic, which is guided by the performance standard. Okay, so we will talk about this one by one. Guided by performance standard. The second one is a learning element. This we have already discussed when we were doing models. So if at all we feel not if we feel that we should go back to that previous video, you can always go back. So the next one is the next component is a learning agent. The third important component is a problem generator. So all these terms are very familiar to us, and if you need further clarification on each of them, then we can always go back to our previous videos. So the fourth one is a performance element. The fifth one is the sensors, or those components which helps us to sense the input from the environment. And the sixth and one of the most important component are the actuators or the effectors. Now let us talk about them one by one, but in a brief manner. First of all, if we are talking about the critic, which is guided by some performance standard, that means this performance standard is well set for a particular system or a machine by a critic or by critical analysis, so that if that performance standard is met, then only we can consider the system to be intelligent. The second one is a learning agent. So we have different types of learning agent like model based agent, simple reflex agent, utility based agents, etc. So those agents, they sense the environment and they work on the environment with the help of their actuators. The third one is the problem generator. This problem generator is another component of this learning agent or of this particular system, which will basically be generating or formulating the entire problem environment or entire definition of the problem in terms of the current state, then let's say the next state. So this we are talking in context to the search, if we are using any search related problems. So all those steps which we talked about previously, like whether it is the goal state, what should be the path, cost, etc. So all of them will be specified by the problem generator. The fourth one is the performance element. So this will actually be measuring how good the agent is performing at any given scenario. The sensors, it is extremely important because without this we will not, or our system will not be able to perceive the environment, because only through the sensors we will be able to perceive the environment, and hence sensors is a essential component of a learning agent. And finally the actuators. So these actuators, they are basically related to the actions that it will be performing after sensing the environment. Now this entire process of learning as well as the general components of a learning agent is very important and essential when it comes to an unknown environment, because in order to make a machine artificially intelligent, the system has to learn from the environment, preferably an unknown environment, and work accordingly in order to get the best possible result or best possible option. So talking about the different forms of learning, before we go ahead with the different kinds of learning, we have to understand that learning is useful as a system construction method. That means we have to expose the agent to reality rather than trying to write it down. So instead of basically directing, so if we are not supposed to direct, or we are not supposed to uh, write down the different outcomes of learning, rather than we have to expose the agent to reality. That means, suppose if we are learning about any topic and we do not know, and we are not expressing our views on it, that means essentially our learning is not fruitful. So we have to expose it to reality. That means we have to make use of our learning and express some views on that particular topic. And similarly, learning is one of the primary process which might modify an agent's behavior. So it is one of the primary process which would modify agent's behavior. That means if I'm having some perception that I will reach from point A to point B in 10 rupees, so this was the perception initially I had. But after I learned about the environment, suppose the environment um is that from point A to B the road is not good, the road is not good, or maybe there is traffic there. So which might lead me to, or which might require me to follow a different path, let's say via A to D, C, and E. So if I'm supposed to take this particular path in order to reach A to B, so this learning will actually modify the agent's behavior, okay, or the agent's decision. Basically, not only behavior but the agent's decision would be changed because of learning in order to improve the performance. Now, moving ahead with the different types of learning. So talking about the broad categories of learning, we can classify them as, let me write it down, types of learning. So if we are considering the different types of learning, so this is primarily divided into supervised learning, unsupervised learning, supervised learning, and then we have one more learning broad category, which is reinforcement learning. So let us first discuss about the supervised learning in detail. So supervised, the word itself suggests that essentially it works in the kind of a process which has a supervisor associated with it. That means there is someone who would tell us what is correct and what is not, right? So it will involve certain amount of training data which we will be using in order to train our machines or train our system, and then we have to provide both the input and the output. Now this we will be explaining, or we will get a clear explanation with the help of a real-time example. So suppose I have suppose there is an election which is going on in your college, and there are different students, let's say A, B, and C. So A, B, and C are um, are involved in that particular election, and these three different people have three different group of supporters, or multiple supporters for each of them. Now we also know about a situation in which we have a poll box, let's say a box where the ballots are been, this is, let's say, a poll box, and here the ballots have been collected, the votes for all of these three people have been collected simultaneously. Now what we will try to do after the election is over, we will try to estimate who is going to win and who is going to lose, okay? So now suppose there are around 500 people in your college, or 1500 people in your college. So what we will do, we will just we will just collect the data from this 1500 people as to who they would be likely to vote. So once we get that condition, we will try to fit it into our machine that so many people, like there is an input and there is also an output here. Okay, so input and output. So we will be mentioning all the inputs, that means the estimated inputs, and we will also be generating the output for the same. That means if this is the situation, A will win. If this is the situation, if B gets this number of votes, then B will win. And if C gets this number of votes, C is having this much of probability to win, and so on. So input and output both we will be providing, but this is entirely based on estimation, and this is entirely based on a supervised concept. That means we will be giving the providing the data, no wonder, and also will be generating the output for the data, but this is not the actual data. Okay, this will not be the actual data, and after that we will be implementing some sort of learning algorithm here. Okay, so now learning algorithm essentially will be able to classify the new data or the new input, which is actually the real data or real input in future. Okay, so it will be able to perform classification, and there are several classifiers or several algorithms, like naive bayes is one of them. So this naive bayes algorithm will be trying to classify this particular input and output and build a model of the same. So once this model has been generated, any new input from the poll box, whenever this actual counting begins, so whenever this new input goes inside this model, it will be generating an output, and if the output matches with the output which was originally present or originally predicted by the supervised classification, that means the model has been accurately trained and any new information can be accurately classified as the winning team or the losing team. Okay, so here what we are trying to do is we will be providing both the input and the output. That means we will be having a supervised concept of the input and output along with some learning algorithms, and then we will build a model of the same. Now after the model is developed, any new information which is coming to the model will be classified based on the already existing training which is been given in this particular model. So this is basically the training data, and whenever we are actually sending getting the real time data, that would behave as the new data which we can test the model against. Okay, so we will be training the model based on the estimations and based on the supervised concept, and then we can test it against any data, that particular model, for its accuracy. And if the output is matching with the training data, that means if the output is matching with that particular output which was initially present in the training data, that means our model is accurately trained. Okay, the next important concept or next important learning is unsupervised learning. Now this unsupervised learning, this is exactly the condition of a um, situation where we know only the inputs. So in this situation we will have only inputs and no outputs. That means suppose a baby is born. Okay, this baby will not be able to identify who is a male, who is a female, who is a baby or who is not a baby. Okay, or what is an animal. So all those things this baby will be able to just, if we do not teach the baby anything and simply expose this baby to the environment, then what will this baby do? As and when this baby grows up, it will try to cluster the people. Okay, it will try to cluster the people. That means suppose a person has long hair and uh, here and that person is wearing, let's say, a dress like, or is dressing like that of a woman, then the baby will be categorizing it into female. Okay, similarly some people with short hair and dressing like men, they will be the baby will be categorizing them into males. Okay, and smaller people, it will be categorizing them as kids. and who walks on 4 foot, the baby will be classifying or categorizing them as animals. So these things the baby has not been taught. It will simply use the form of clustering, or it will simply go on clustering based on the different features each of these groups would have. So whenever a new person comes, it will, and the baby will analyze, and if that person has long hair and is dressing like a woman, it will fit into the female. Of course there would be some inaccuracies associated. However, this learning, it happens by itself. That means, how it does it happen by itself? It simply clusters the information into different groups, and based on the information features of that information, this clustering would be helping in order to classify the different components of the environment. Okay, so here we are not showing the baby that this is the output, this would be the output, okay, or this is the input and this is the output. We only have inputs. That means the baby is bombarded with a lot of figures which is outside in the environment, and the baby will be finding out the different features it has and accordingly cluster them into different groups. Okay, so this is unsupervised learning. We are not directing the baby for anything. However, in our previous model, we, in the training stage itself, we are giving the input and the output. That means if this number of votes is received against this symbol, this party is sure to win. So this kind of concept is not there in unsupervised learning. In unsupervised learning, everything happens with the help of the clustering technique. So it will cluster the required information, the required features for each of the groups, and it will classify them accordingly. One such unsupervised, popular unsupervised algorithm, learning algorithm is K-means algorithm, which will help to categorize the different information based on the different groups. Now similarly, the last broad category of learning which we will be discussing is reinforcement learning. So reinforcement learning, essentially it deals with some sort of reward and penalty policies. Okay, so reinforcement learning, we have some rewards or penalty associated with each of the activities or each of the actions which we do or decisions we take. It is also known as cue learning. Okay, so now talking about reinforcement learning, what actually happens? So suppose there is an agent. This agent will try to do some action on the environment, and based on this action, the state of this agent will change, as well as, and the environment will change, as well as some reward or penalty would be given. Now what do we mean by this? Let us take a very basic example. Suppose I have 10 rupees with me, and this 10 rupees I will be giving to a shopkeeper. Okay, so this is a person, this person has 10 rupees and he is giving this 10 rupees to another person, which is the shopkeeper. The shopkeeper will take this 10 rupees and give one fruit to this particular person, or to this particular agent. Okay, so to this particular agent. So what happens here is the state of this agent changes immediately. That means he is left with no money, as well as the state of the environment also changes, because now he has lesser number of fruit with him and the agent will have one fruit with him. That means he got a reward for the action which he has done. His state got changed and he also got a reward. That means it was a positive decision and he got a reward for the same. Now suppose he does not have any money. So if he does not have any money, or let us take in another situation, he does not have any money and now he has he does not have any more 10 rupee note, he has just a 5 rupee note. So now the person will give this 5 rupee note to the shopkeeper, And when this person gives the 5 rupee note to the shopkeeper will not give him any fruit. So in this scenario, what will this person realize? Agent A will realize that with 5 rupees he cannot buy one fruit. Okay, so it is associating one penalty, that he did not get any fruit with him although he has given 5 rupees. Okay, so in this scenario, what will happen? The agent, this particular person, will formulate a policy that one fruit will cost 10 rupees, and even if I give 5 rupees, I will not get half of the fruit. Okay, so this is a policy which he has generated. So here what happens, as long as there is a correct step taken, the state of the environment also changes, as well as there is a scope of getting reward for the correct decision which has been taken. However, a penalty is also associated. In this particular example, the penalty was not associated. Okay, he did not get, that could be a penalty, but in some other situations there might be loss of money, or there might be loss of time, or loss of resources, and at that time there will be a penalty associated for this particular action to the environment. So this is basically reinforcement learning, and these are three different broad categories of learning: supervised, unsupervised, and reinforcement learning. Generally we expect our machines to follow or adopt unsupervised learning, because it is not always possible to associate a supervised concept to it. However, most of the experiments and most of the learning, it takes place using supervised learning, because it gives more accurate, or it gives an easy understanding of the problem. However, in order to make our systems much more intelligent, unsupervised learning and reinforcement learning could be a better option. So that is all from different forms of learning, as well as learning from observation. We will talk about inductive learning and other such associated topics in our subsequent sessions. Thank you.